Everybody, this is page 376 and 377. We're going to be talking about the determining measures inside and outside of circles. We've been doing a lot of circles, angles, critiquing, proofs, etc. Please, for this video, have the interior angles of a circle theorem. Find that card, go back to page 366 and remind you of what that said in order to be successful on part of our lesson for right now. But we're actually just going to put into practice something that we've learned. So we're going to reason abstractly and quantitatively. We're going to construct viable arguments and critique the reasoning of others. Have something to write with, have something to maybe highlight, but along the way, let's solve some problems. For example, Aubrey wants to take a family picture. Her camera has a 70-degree field of view, but to include the entire family in the picture, she needs to cover a 140-degree arc. Well, let's explain what Aubrey needs to do to fit the entire, family in the picture. Use the diagram to draw the solution. Honestly, if the camera only has an opening of 70 degrees and she needs to fit 140 degrees of a circle into it, she's too close. We would just tell her, hey, just back up, right? Back up. And specifically, how far she should back up, she needs to move back to a point on that circle where the arc her family is standing on is 140 degrees. Because if she makes the move to an inscribed angle and creates that half of 140 is 70. Pause the video and write, excellent, yes. The inscribed angle theorem is what we're using for number one. Boom. Inscribed angle theorem. Let's go to the next one. Yesterday, Miss Angle told her students how to determine the measure of an inscribed angle. She knew she was going to be a teacher in mathematics. Mitchell told his classmates that he finally understood why a circle is always 360. So let's use triangle PA drawn in the diagram to explain what Mitchell was thinking. And by the way, angle P plus angle A plus angle W is 180. But across from angle W is arc PA, and across from angle A is arc PW, and across from angle P is arc AW. Aw. Got that coloration? Let's use it. Mitchell is realizing that the sum of the angles in a triangle, not a circle, is 180 degrees. So angle P plus angle A plus angle W is 180. But these angles are drawn inscribed in the circle, so they, being inscribed angles, are half of the measures of these arcs. So whatever angle W is, you would double it to get arc PA, and double to get arc PW, and also double angle P to get arc AW. So doubling 180 degrees gives you 360. What a roundabout way of proving to yourself that you know how big the measure of an arc or of a circle is. Let's go to page 377. Don't reveal it yet. Okay. Sophia says that using only the given information in the diagram, she can determine all of the unknown measures in the circle. And I'm going to acknowledge that we are going to use interior angles of a circle theorem. I don't have the diagram on here, but I should put that diagram on here because this is the diagram for the interior angles of a circle. She says she can determine all the unknown measures of the circle, including arc length or arc measure of 5 and arc measure of 6. Well, you know what? She's honestly right partially. She can definitely find the measure of angle 1 and angle 3 because you subtract this number. You add. You add these two numbers together and you divide by 2. That is what the interior angles, you add them up and then you divide by 2 to get the measure of angle 1 and angle 2. And then you know what? She can also find the measure of angle 2 and angle 4 because the linear pair postulate says that two angles that form a linear pair must be supplementary. They must add to 180. So she could find the measure of angle 2 and angle 4. The only thing is she can't specifically find the measure of arcs 5 and 6. No matter how you tilt the crossing secant lines through the circle, whether they cross here or 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 here, all you know is the sum, how much 5 and 6 add up to. but you do not know specifically what they are, because changing your location where the secant lines cross from right here to maybe a different location, a different location, a different location, etc., your 5 and your 6 as angles will change. These angles are not going to change. Those arc measures, but you might be covering a different section of the circle, C, and when you cover different sections of the circle, something has to be adjusted. So specifically how big 5 is and how big 6 is, they're going to change. They're going to change constantly. They're going to change, where they still stay in the same proportion, but you don't know right now how big they are. Sophia doesn't know. That is some intelligent thinking right there. Let's take a look, just as a hint. Look at what we're going to do as we finish out this lesson. We're going to apply the theorems to solve problems. So I will see you on page 378 and finishing up our lesson. Thank you guys so much. Have a good day. See you in the next video. Bye.